Hi everyone, Mr. Markwick here. Today's video is a bit of an introduction to residual plots. So far in the course, we've been looking at two sets of variables, usually numerical variables given in the form of x and y values, or those explanatory variables and the response variables, and plotting those onto a scatter plot and drawing a line of best fit using our graphics calculator. We've been using the least squares regression line method to draw that line of best fit. However, it's not always appropriate to model the relationship between two sets of variables with a straight line. So if we look at the scatter plot just here, you can see that there is a strong relationship between the x and y variables, which would give a strong value or high value of r and r squared, but you can see it's not linear. Okay, so to further assess the appropriateness of a linear model, we analyze the residuals, and that's what we're going to be looking at today, how to calculate those residuals. In my next video, we're looking at how to actually analyze those. So for each data point, residual is given by the y observed value minus the y predicted value. Now, the y observed value comes from the real data, okay? So if I was looking at a set of data, which I have here in my example, the observed value here for my first point is 7. However, the predicted value comes from the model. So if I substitute x into the least squares regression line equation, it should give me 7, but won't necessarily always give me 7, okay? So the difference between those two values, the difference between, in this case, the 7 and what the predicted value will be from the equation or the model, is my residual value, okay? Now, if we look at an example here, so this point here, which is just above the least squares regression line, the difference between that are actually y observed value, the real data point, and the line, the model, okay, the least squares regression model, is what we call the residual value, okay? And if the point is above the least squares regression line or the line of best fit, we say it's a positive residual. If that point is below that line of best fit, then we say it's a negative residual, okay? So what we'll be doing today is drawing this residual plot, something that looks like this, where basically it tells us how far these points are from the actual model, okay? Let's look at an example and try and talk through it that way. So here is a set of data with our x variables or our explanatory variables in that top row, and our y variables or our response variables in that second row. First part of the question says to find the equation of the least squares regression line. This is something we've already done before in the form of y equals ax plus b, where a is our gradient and b is our y-intercept. What are those values? That'll determine what the equation of that least squares regression line is. So in your graphics calculator again, head into the stats function. Okay, and to save a bit of time, I've put those 5 values in list 1 for x and those 5 values in list 2 for y. And then we're going to go to graph. Make sure your graph is set up to a scatter plot with x in list 1 and y in list 2, which it is here, and ask your graphics calculator to draw that scatter plot for you. So there it is, and you can calculate those values of a and b through here. So a is equal to approximately 1.61 and b is equal to approximately minus 0.23. So the equation of that least squares regression line is y equals 1.61x take 0.23. Now, again, we can draw that least squares regression line as well by then pressing draw, and you can see it heads through there. The next part says to calculate the residuals. Now, we're going to be using the calculator to do this most of the time, but I'm going to show you how to do it by hand, just for one of those values. You see it's a little bit of more of a time-consuming process. So based on the equation y equals 1.61x take 0.23, what I'm going to do is I'm going to substitute in my x value from this first coordinate, which the first coordinate is 3, 7. Okay, so sub in x equals 3. So it becomes the y value is predicted to be 1.61 times by 3, take 0.23. Go ahead and put that into a calculator, and it'll give you 1.61 times by 3, take 0.23 is 4.6. So the residual value there is, the predicted value, my apologies, is 4.6. And the residual value is the difference between the y observed value and the y predicted value. So I'm doing basically here 7 take 4.6, which will give me 2.4. So the residual of that first set of coordinates is 2.3. Now, the y predicted value only helps you when you're working it out by hand. The graphics calculator will solve this column for us, and I'll show you how to do that right now. This is really important for you to set this up in your calculator in preparation, hopefully, for the test and the exam. So once you've got that line of best fit, or that least squares regression line in there, head back out to the list. And if you just press Shift Setup, head down here where it says Residual List, and we're going to set that to List 3. And hit Execute. If I exit and ask it to draw it for me again, draw, and then head back to that list, there are the residual values there. You can see I was a little bit off because obviously I rounded my model. They're using more exact values. So the residual value for the first set of coordinates is 2.39 exactly, close enough to 2.4. The next one is minus 2.2, which suggests that that point is below the line of best fit, or that least squares regression line. For the third set of coordinates, it's 0.6 rounded up, okay, which is slightly above the least squares regression line, or that line of best fit. The fourth value is minus 3.3. Again, we'll round that up, so minus 3.3. And the final value there is 2.5. Okay, so they're my residual values, which suggests that 1, 2, 3 of those points are above that model, or that least squares regression line, and 2 of those points, 1, 2, are below that least squares regression line, or that line of best fit. Okay, it says then to draw that residual plot. Now, again, I'm going to show you how to do this using the graphics calculator. So once you have list 3 set up with your residual values, what we're going to do is we're going to look at doing graph 2 as a residual plot. We already have graph 1 set up as the scatter plot, and we've drawn that line of best fit, or that least squares regression line. So leave that one as it is. Head into F6 to set your list 3 for graph 2. So I want to set this as graph 2 and change the Y list now to list 3. Okay, that will then show the residual plot, which is what we're being asked to do here in question C. So exit, and we draw graph 2. It'll look like this, okay? The x-axis will be horizontal, and those points will be either above or below, depending on whether there's a positive residual or a negative residual. So this point here, you can see, corresponds to this value here, positive 2.4. This value here corresponds to this point here, negative 2.2. This point here, 0.6. This point here, minus 3.3. And this point here, positive 2.5. So that's a bit of a quick introduction into working out residual values using your graphics calculator and drawing that residual plot using your graphics calculator. In my next video, we're going to be looking at actually analyzing and I guess talking about what those values mean in terms of correlation or relationship between 2 sets of numerical variables. So hopefully that helps, and thanks for watching.